Welcome, welcome, welcome. My name is Jeffrey Palermo. I'm your host for today's training. And today we're going to be talking about increasing speed. And we're going to see how projects should accelerate over time. Just quick logistics to get out of the way. Um, I've got a lot to cover, and I'm going to go quickly through some portion of it. If you do have any questions, then you can just drop a question in the Q&A window, and we'll have plenty of time for questions after I go through the initial material. And I'll stay here long enough so that everyone gets the questions answered. And I have uh, Chloe assisting me with the chat. So any questions on resources that I mentioned or links or how to access things, she'll be happy to help you there. And if I mention anything that you haven't seen before, if you haven't been following our webinars, then she'll help you out with that. Okay, so let's get into our training. Um, Increasing speed. Projects should accelerate over time. You might be wondering why this training wasn't earlier in our five pillars training series. After all, if your software project is running behind, then you're going to need to speed it up. And you might be frustrated with how long things take. Because after all, you need your software team to move faster because you need to get capabilities to market so that you can stop investing and then start reaping the return on that investment. So speed in our software projects is important, and we do need our software teams to move as fast as the business needs them to move. Um, and A quick overview. ClearMeasure is a full-service software architecture and engineering firm. We serve companies that are using .NET and Azure and other Microsoft technologies, and we do three things. We build and deliver custom software. We help and turn around troubled projects, and we inspect software systems and projects and offer advisement. And this training is part of a series based on the book, The Five Pillars: Leadership for Effective Custom Software. And you can find that anywhere on Amazon, Kindle, hardcover, softcover, audiobook on audible.com. But if you just send me an email or request for an electronic copy of the book, we would be more than happy to send it to you. And if you know somebody on your team or someone who would benefit from the book, then just send me the link or send them the link. And we'd love to get this useful book in the hands of everyone. And you can find me on LinkedIn, or my email is right there on the screen. I'm pretty easy to find. Okay, so the agenda for this training is we're gonna talk about what speed is. We're gonna talk about estimates, the best way to estimate. We're gonna talk about design decisions and important ones in order to actually have some good estimates and a good process, and then also talk about how to eliminate waste, maximizing the amount of work not done. And we're also going to talk about the impact of quality and stability on speed. All right, so let's get into it. So let me set the stage. You see other companies rolling out software very quickly, and it can be frustrating if one of your teams just can't figure it out. You may even see them working hard. They're working nights and maybe even working on weekends. You know that they care. You see the effort is there, but it's just something isn't clicking. They're taking too long, and it seems like with each release, it seems the team's pace only gets slower. Now, a healthy project has a productivity curve like the one on the left. But far too many teams experience the curve on the right, logarithmic. It's like as farther we go, the slower we go. Eventually, at some point, we declare that it's the software's fault, and the solution is to what? Start over and rebuild it. Now, this might happen, years down the road, and we might call it legacy software and blame it on a technology refresh. But the point is, if we are going slower and slower and slower over time, there's something wrong. So the most common metric for speed is in the custom software development world is something that we can call throughput. And this is the amount of output or items passing through a particular process. Some teams like to call this velocity. And this imagery can be helpful because velocity in physics does equal distance divided by time. If the team does the wrong thing, then, well, there is no distance. And so velocity implies that we progress in a meaningful direction. And the word you use, it really doesn't matter as much as picking one and tracking it. It starts with defining your unit of tracking. So in software, the item is a change. The change could be a feature, it could be a bug fix, it could be a security patch, it could be a change to an existing feature, modification, enhancement. Like any other value chain, you have to have visibility to your unit of throughput. You need to have visibility into the steps in the value chain, and you need to know the stage where the change is in production and being used by happy users or customers. But do you have absolute clarity on where the value chain starts? Do you have visibility into every station of work between the start and the finish of that value chain? That's important. The software development lifecycle, the SDLC, it's a very, very long in the tooth pattern for the stages of a software application. The long-standing stages in the software delivery process, according to the SDLC, are requirements gathering and analysis, and then planning and design, and then development, and then testing and quality assurance, and then deployment and implementation, and then maintenance and support. All right, these are multiple decades old. And um, while they are old, the concepts, they're still the same. We need to gather ideas and analyze them. Then we have to move them through implementation to a production environment and support their use. There are, stages in the middle that need to be called out because of the nature of the work. However, Agile has completely inverted the application of the software development lifecycle. Instead of putting a lot of software features in the first stage requirements and then moving them kind of all through in batches, instead, we lay out the stages and then we move through a single feature one at a time. The smaller the unit of work, the better. And Agile has really proven effective in dispatching smaller and smaller units of work. It really has. In my book from some number of years ago, the book .NET DevOps for Azure, uh, one of the things I write about is to suggest that a software development lifecycle that's optimized for fast-paced software delivery, has a normal process. And just as in high throughput processes and in other areas of your business, the research behind Eliyahu Goldratt's theory of constraints book, that research is your friend. You want to ensure that your software team has identified the stages that a software change needs to move through to be delivered to the software system's customers. You should expect a scorecard delivered weekly, as mentioned earlier in this training series. You not only want to know the overall throughput of the team each week, but you also want to know the average age of an item in each of the stages of the process. This is going to help you in identifying bottlenecks and breaking through those bottlenecks. The Phoenix Project, a book by Gene Kim, in that book, we see helpful language around the three ways of DevOps. Those three ways are flow or systems thinking. The second is amplifying feedback loops, and the next is continuous learning. To understand your team's current throughput, you have to track the flow of software changes through your current process. And if you don't know the numbers, then you can be sure that your team is moving unnecessarily slow. It's just going to be that way. And just starting to track these metrics is going to yield some low-hanging fruit that you'll be able to take advantage of. Now, a common symptom of ineffective teams is chronically wrong estimates. Not just wrong, but really wrong. And in business, you have to be able to set dates and deadlines. You just have to in any department of business. You have to be able to schedule things. And while significant transitions might not be able to be planned precisely, it's not really okay for the estimate of something to be, quote, this decade or I'll get to it at some point. You have to get down beyond, oh, I might get to it this year, or I think I can get to it this week. You have to you have to get down to a smaller level of granularity. A software team, it has to be equipped with a process that lets them guess if a feature is going to happen the same day, the same week, or next month. Yes, it's a guess, but we have to equip those guesses to happen based on something. Regardless of the answer, you have to have some actual track record and not an answer that the developers themselves don't even believe. And sometimes the answer is, I have no idea how to make this change. I don't know how to do it. I haven't figured it out yet. And the truth is always going to be better than relying on an answer that turns out to be a pipe dream. So the mapping of the value chain is the foundation of giving rough estimates on a single item. If items typically take 3 days to get through user interface design, and then another 3 days to get from code complete to the point where they're validated by the product team, then there's no way that any visible change is ever going to be less than 6 business days. It's just not going to happen. So tracking the average number of days and hours per stage in your process is your key to knowing what to expect even before you ask for a change or know any details about it. Just add up the average stage durations for the whole process. And chances are that the first time you do this, you're not going to be happy with your overall average cycle time for any given software change. But it's your starting point and you optimize from there. And by optimizing, you make process changes to get each stage down to minutes and hours down from what it might be now. In the process, you identify areas of your software, your software development lifecycle, your software process that they might not be adequately staffed. You might not have enough people. You might discover that you have too many developers and not enough analysts. You might find out that one station of work doesn't even have anyone paying attention to it 85% of the time. And items just go there and sit and wait and gather dust. So measuring is your tool for clarity. And you'll find out that you're going to find out why your team on your team, it seems like that you're moving slowly. This is the beginning of your journey to increase speed. It's just the beginning. So, a lot that we've reviewed. And for some of you so far, maybe you haven't seen anything new. It doesn't help much to confirm what you're already frustrated about. Your team and every team is terrible at estimating the effort necessary to deliver a new piece of software functionality. Either the estimate of effort is way off or the estimate of how much labor was available to work on it was way off. But either way, you've learned not really to trust anything from your software team that's labeled as, estimate. And it's not the fault of the software engineers or the analysts or anybody working on it. Estimating software features really isn't a practice that's done well anywhere in the industry. You might assume that others do it well somewhere at some other company, and you might assume estimation methods. Surely there's some out there that have been proven. You might assume that someone somewhere does it well. Surely. Well, you'd be wrong. It's just not a real concept in custom software that's widely um, widely taught or widely practiced. And it's certainly not taught in universities. Highly effective software organizations, they know this, and they don't even attempt to estimate at this high level. Instead, they measure and forecast. Then they break down work and count individual tasks. And by the way, this is the same as manufacturing. It's all the same concepts. But after breaking down work and counting individual tasks, when you add up all of the individual tasks, you can forecast a date that software features will be ready. This is a mathematical system, and this system forecasts the ready date for any kind of feature or set of features. But in this process, no one is forming any opinion on the level of effort. It's a forecast algorithm based on measurement. So let's talk through an example. All right, so software development, it's an empirical process. We've known that for a long time. And that means that planning is done based on observation of how the work is going or based on experiencing the flow of work. So creating a standard workflow has to be the basis of the process. And what does this mean for software? Well, it means that trying to feed the software team with feature requests that wildly differ in size, it really sets them up for failure because no consistent process can then emerge. You can't arrive at a standard process if a feature request for changing some screen text is fed into the same process as a feature request to launch a new e-commerce shopping cart in a new market. You have to start by breaking down the work before any code is written. Break down the work. After all, um, you've got software organizations out there that are less mature, and in those, it's easy to think that all the time that's taken in the software process is taken by the software engineers writing code. After all, you may think, isn't that why so many software managers ask the software engineers for the estimates in the first place? Because surely the coding is what takes all the time. No, it's the mistaken assumption that the work needing to be done is with hands on the keyboard writing code. And that's just not the case. So you have to break down larger features to transition to a counting-based planning method. Your engineers can help identify if any work items, can't be code complete the same day it started. That's a pretty good gut feel. And those items might need further analysis so that they can be split into multiple pieces. When I say one day, maybe it's 2 days, but some bounded size where you pretty much know in your gut if something's not going to fit into a very small period of time that you can be pretty confident about. But each piece, it should be of a size that the code can be completed in this very short period of time. I like talking about a single day or 2 days because typically I've seen a lot of software engineers be pretty good about identifying when something cannot be implemented in one day or at most 2 days. Now, we're not discussing software engineering practices here. The, code complete, it really should include the completion of the item of work so that it works as defined and also includes all the team standard items like automated tests, any resulting refactorings and deployment adjustments if those are necessary. Now, at first, your team might insist that some items can't possibly be broken down any further, and this is where your leadership comes in. Development tasks that are larger than a day or at most two, those are notorious schedule saboteurs. And here's some of the things you might want to listen for, and quoted right here on the screen. Here's my update for today. I worked on the such and such feature yesterday, and I'll continue working on that today. Or you might hear, well, I had some issues with the such and such function, but I think I figured it out. I'll validate that today, and then I'll get back to finishing the feature. Or you might hear, well, I laid out the screen and then I had some questions about such and such. So I'll be calling Peggy today to see how it should look. Or you might hear, this task is a bit bigger than I thought, but I hope to be finished with it today or tomorrow. Or you might hear, I need to talk to or contact so and so about this feature and then I'll finish it up. So all of these, they all say the same thing. They all say this feature was too big to begin with, and I'm doing some unfinished analysis along the way. My work is highly inefficient, I'm stopping and starting, and I really don't see how I'm stuck here, and I'm wading through the mud, and I really don't know when I'll be done, but I'm working hard and I'm trying. That's really what that means. But when you've broken down every development item into a size that can be fully understood and accomplished reliably in a single day, or at most two, then you can move to a math-based form of forecasting your schedules. You can then just count how many items need to be built, how many items are on your Kanban board, and then you can measure how many items your development team is delivering each day and each week. This is the foundation of a repeatable standard process. But you have to ask, oh, okay, how do we break things down? Well, the answer is through design. So let's explore that. There's a lot of ineffective teams that don't recognize the different types of work inside the team or the difference in team member skills. Software developers and analysts are not interchangeable. Some are very good at analyzing data and facts. Others are great at generating options and analyzing differences between them. There's four general design categories or categories of design decisions that have to be made to be ready to translate those decisions into machine instructions by writing the code. So, design decisions before hands-on keyboard to write code. If those design decisions aren't made by the time we do put our hands on the keyboard, then the programmer is going to be forced to make those decisions simultaneously with coding. And the result is going to be based on really the personality and experience of the engineer who happens to be working on the feature. And that's opposite of a standard repeatable process. So, what are these design categories? All right, let's dive into them. The first is conceptual definition. This is the concept we're thinking about or the business objective that we have. This is where we do business level design. The why, the what, the by when do we need it accomplished? For whom? What is the goal? What are we trying to accomplish? What non-technical outcome is desired? Is there an acceptable return on investment? If it costs more than such and such amount, might we cancel it? What customer group needs something? What are the constraints? All those types of questions fit into this category. The second category is user experience design. This is where we ask where, how. This category of design generates options for how it might work and how it might look, and then we select the option. There are always multiple options for how a user might use a particular software that does something and meets a certain goal. This stage disqualifies some of the options that don't meet the constraints already identified. If the option or the feature includes the need for something visible, like a screen, a wireframe, or a screen sketch, well, then we design it at this time. Even if it's invisible to the eye, every software change will be experienced by someone in some way. Even if the feature is just moving data around, it's going to have a user experience. This design category determines how a user or stakeholder of the software is going to be affected by this feature or change and how they use it. And later, when we do user experience testing, we're going to validate these things. Some call it UAT for literally user acceptance testing. In this stage, we're testing for these design decisions. Here is where we decide what the observable behavior of the software should be to accomplish the objective that we're actually working on. The next design decision is technical design. In here, we need to decide what architectural elements are needed to implement the chosen solution. What has to change in the software? How many individual development tasks are required to make this change a reality? Start breaking things down. This design category creates an implementation plan for the feature by breaking down the work into day-sized tasks. Again, or at most 2 days. Or a task can be assigned to a software engineer here, and you know, we need to have some hope of completing it quickly. That's the point. Okay. So don't get hung up on 1 day or at most two. We don't want unbounded tasks. Now, invariably, features are too big to be implemented quickly by one person, the entire feature. So in this stage, this is where a very senior software engineer or architect figures out how to break down the feature into its independent parts for the most efficient and predictable implementation. Besides how the features should behave, designing how to fit it into the existing software system ensures that we don't accidentally spin our wheels when we attempt to write the new code or refactor existing code. All right. So that's technical design. The final design decision before code can be written is test scenario design. In this stage, we ask the question, when is it done? This category of design is the decision point for knowing whether or not a new feature is finished. We design the definition of done, what's in, what's out. Every software feature has more than one pathway to experience it. And by listing out the usage scenarios, defined as scenarios to test, we can understand what to check to ensure that nothing actually slipped through the cracks. The list of test scenarios is also a development task, since automating test scenarios really is the best way to ensure that they run continuously. And the practice acceptance test-driven development is relevant here. But with these four design decisions, before we put hands on the keyboard to write the code, we actually empower our software engineers with all the information and decisions needed to implement the new change really quickly without guesswork and without stopping to fill in gaps or obtain, answers to open questions when we miss something. All right. Now, I want to reinforce. I said this before. No one does estimating well. Estimates are like opinions. None are true. So we want to use math instead. Um, when it comes down to it, effective software teams make design decisions in these four categories before starting on the code for an item. Ineffective teams miss one or several of these design decisions or don't even have categories for design at all. And the software engineers are just constantly filling in design gaps while writing the code. At the executive level, you have to be able to set deadlines and plan some big software initiatives. So, to bridge the need to set dates and know if the team will deliver, you have to run a standard, repeatable process for all software work. So, break the work down into a standard sized chunk. All right. Um, while you're doing this, ensure your team is making all those necessary design decisions for each feature before the code for that feature is started. Count up the number of development items, not requested features, the development items, the thing that we broke down in the technical design stage. Count up those items being accomplished each week as they're being done. And just like running any other kind of flow-based business process, you'll be able to project into the future when things are going to be are when things are being completed, but at the same time, when things are going to be completed. And then we'll be using math to make our projects, not estimates that are based on subjective human factors. All right. So one of the agile principles that we've reviewed in previous training sessions states, quote, simplicity is the art of maximizing the amount of work not done. And in software teams just tend to increase scope beyond what's necessary. It just happens. And then the wrong process doesn't allow for cutting unnecessary scope. So you, as the leader, whether you're the manager, an executive, or architect, or leading a group of developers, you as the leader, you don't care about any single feature. You only care about the big picture. You have business objectives. If those objectives can be met with two software screens instead of three, you're happy. So the third way of DevOps, which is continuous learning, uh, is important here because we're going to figure it out along the way. As software is developed and rolled out, every team learns how users need the remaining capabilities that have yet to be developed, and those remaining backlogs of features, that's really just a pile of hypotheses. And about two-thirds of those hypotheses are wrong, if you believe the research. So assume that your backlog is no different than what is average out there in the industry, and actually be open to cutting or radically changing any feature that comes through. It's okay, and it's oftentimes the best thing for the project. All right, let's talk about quality and let's talk about speed, because if you lose quality or stability, you're going to lose speed. You're going to lose that speed. We tend to cover quality and stability before speed, because quality and stability are prerequisites. By generating defects, lack of quality, you reallocate your team's time to fixing those defects. You waste your development capacity on production by passing through problems that turn into life side issues. You'll never have speed if you don't first establish and maintain a high level of quality and then do what's necessary to achieve stability as your software runs in production. Only then is it even possible to measure and optimize the throughput of features and useful changes that you're working on. So you want to ensure that your team spends almost all their time on new features. If they aren't, then you aren't yet ready for this phase of the five pillars. Okay. All right. So I want to stress why it matters. By chasing speed, and it's really tempting to chase speed, you're going to lose quality. And when you lose quality, that's going to cause you to lose speed. Okay? That's kind of how it works. That's the dynamics of it. And if you don't keep them in that order, then instead of loving this game of software, then your team is just going to kind of feel like they're trudging through a tar pit of a software system. Okay. So reminding you that this training is the fourth in the series on the five pillars. We started with creating clarity, then moved through establishing quality and achieving stability. And without those first three, you won't increase speed. Your team's going to constantly be slowing down. All right, let's kind of transition into some of the essential practices that you can implement today in order to increase speed. Okay, first, make sure that every needed activity in your software development process has a column or a status in your work tracking system. Make sure that you have clearly assigned ownership of that class of work for each status to a person or maybe a few people. Set standards for the completeness that each stage has to adhere to before promoting the item to the next stage. And make it okay for somebody to move an item backwards if it's not ready for the next stage. That's okay. And then measure the throughput of each stage on your team's scorecard. This is going to alert you to bottlenecks, and it's going to empower you to be able to forecast what the team can accomplish based on the capacity for work that's being measured for each stage. And finally, don't hesitate to move people around when you realize that more labor is needed to be dedicated to different stages. And with this process fully implemented, it's really common for you to realize that you actually may have too much capacity dedicated to the development of the code and maybe not enough to test design or user experience design. And that's okay. You learn new information and you can adjust. Okay, so this training has been on increasing speed. That's the fourth pillar of the five pillars. Make sure that you have the book in whatever format you like, the hardcover, softcover, audiobook, or ebook. And you can download the study guide for your team to help guide through some really useful and deep retrospective conversations. So appreciate that. We want to get the book in the hands of every person. And for increasing speed, we do rely on some references that we've used, some prior art, and I'd encourage you to refer to them if you aren't familiar with any of them. Specifically, the Theory of Constraints book has been around for decades and is actually studied in a lot of MBA programs. And the Phoenix Project is also a very popular book. And some useful information in my previous book, .NET DevOps for Azure. Okay. So let me switch over to questions to move into the Q&A portion for today. Let me get my windows together. All right, so here's one question. What's your favorite work tracking system? Okay, so tools. Well, you could actually use any of them. I mean, the really popular ones are Azure Boards, part of the Azure DevOps product. even with Microsoft Teams, Jira is still pretty popular, even with teams of all types. Um, GitHub issues, you can use the GitHub projects. It it doesn't actually have to be high tech. Any tool that lets you have manage a sequence of work, and all the tools kind of help you visualize them with index cards these days and attach things and add more information. But the important part is that you have some type of Kanban style visualization that you can define the tasks and then have some vertical swim lanes that move the task left to right. And lots of tools do that. There's no one magic tool um, that you can use. So I hope that helps. Uh, Here's another question. Um, what about testing? Where does it go in the process? Okay, so actually, I'm going to go backwards and show you the sample Kanban board. Here it is. All right. If you kind of have the development column in the middle where the code is being written, uh, it often is a very usable design to have design and verification sandwich around the code that's in the middle. Whereas you have uh, you have kind of outward in design, where the conceptual definition is kind of design of company executives or product management. And then user experience design is firmly inside software product management. Then technical design is, within the software team, and then test design is just is making sure that we know what scenarios to test for. And so it's kind of like an outward in design process. And then for testing, it's often useful to go inside out. Whereas functional validation is at the team level, user experience validation is at the product management level, and then release validation is checking with any other business stakeholders to make sure we're actually ready to release to our users in production. And so you can kind of see that design towards the development column. Design goes from kind of executive, more detailed into the software team, and then verification starts inside the software team and then goes back out to the business. So it's often helpful to design the structure of your Kanban board with those style of stages. And I would be very happy if you literally made it look like what you see on the screen. But there's no magic in those words. The magic is in the concepts. So make sure that you have the concepts validated. And it's always better to add an additional stage than it is to be missing one. Okay? It's always better. All right. I see Chloe was able to answer some questions in line while we were going through. That counts for that. And that one's done. Okay, I think everyone that did post a question did get an answer. Just last call for any questions. If anybody wants to put a question into the Q&A window before we close up. All the other questions got individual replies and got taken care of. That's good. Um, Going into the future, because I know a lot of you really follow the webinar series for trainings, we're going to do the fifth pillar, which is optimize the team. And then we're going to be moving into some other topics around AI-driven development. Um, and so I'm really excited for that. We're also doing a technology-based webinar this Friday at noon Central on in-service bus with modern in-service bus with the latest versions of .NET. So it's an architectural training on distributed systems. So if anyone is interested in distributed system patterns, then sign up for the in-service bus webinar this Friday at noon Central. And and I'll be joined by one of our architects, Mike Sigsworth, to do that training this Friday. So if you're not signed up for that, do that, and as well as any of your colleagues that maybe need to have some training in distributed systems with .NET ecosystem technologies. So. Okay, here's another question that just came through. Fantastic. So Aaron asks, how would you handle leadership that demands timelines on individual features before being able to accurately run through this process? Well, certainly if you don't have any kind of track record right now, then you're probably in the situation where your estimates are wrong, but you don't, but you haven't been able to jumpstart this process. So there will be a time when you just have to get going. And I mean, it's better off to be honest than that if they want a timeline, it's better to be, in my opinion, constraint driven than guesswork driven. So if there's a feature that's just really important for the business and they want to know a timeline, I then let's turn it around. Let's say, okay, you need this software capability. When when do we need it by? Like, when should it be done? And, if they say, "Hey, I need this capability next week," well, you know, there's some way to implement something that gets some of those capabilities in a week. If they say a month, if they say 3 months, use the constraint to determine your architectural choices and how deep the implementation may be. Because just like if I have a wife and 3 kids and I need some housing, there are so many housing options for a family of 5. And those housing options could have very, very different price points. And some of those are available immediately, like an apartment. Some are available soon, like a rent house. And some might not be available for a year if you choose to build a house. Okay. And in very different price points. But there are so many different solutions. Same thing with every type of software feature. There's so many solutions. So I would suggest asking the leadership of the business to offer some constraints and let the constraints drive the implementation plan. And that'll be helpful. All right. Another question. How do you handle situations where a top engineer or analyst resigns or moves on during the implementation? Well, I mean that happens all the time. That's a problem when you don't have standardization. When you don't have standardization of process, then you always have uh, key man risk, where a certain person who knows a certain thing or has always done a certain thing leaves, and the way that you do that certain thing has been dependent on the personality or the capabilities of the person instead of the the structure of the software process. So, how you handle it, well, if you don't have a standardized process, then you handle it in a chaotic fashion because you're not in a good spot. But how to mitigate that risk is to make the work process driven instead of, unique snowflake of individuals driven. And this is not unique to software engineering. I mean, if if it is uniquely based on the people, then we probably can't call it software engineering. We could call it computer programming, we could call it software development, we could call it coding, but we probably can't call it an engineering discipline, because something that's inherent in all engineering disciplines is the word discipline, is standardization. It is um, doing things within specifications, doing things within tolerances. And that's every field of engineering. I mean, there's fields of art and there's fields of, unique craftsmen where it depends on the personality of the person doing it, and that's all well and good. But in team-based software engineering, where we are looking to increase speed, establish high levels of stability in production, and go faster and faster and faster over time, we have to have an engineering process. We have to have standardization, because that's the only way that we can have a repeatable process that can be measured and optimized, is to actually have an engineering process. and not just be programming computers based on, the personalities of whoever happens to be on the team. So it doesn't solve your problem there when one of the top engineers leaves, but I hope that answer helps. Okay, looking to see if there's any other questions that came through. Looks like we're good there. All right. Well, thank you so much. If any of you have not gotten your complimentary electronic copy of the book, just make sure to request it and let's get it over to you. And look for some really exciting announcements to come involving artificial intelligence for .NET teams. Make sure that you subscribe to the newsletter and the Clear Measure YouTube channel. And I didn't mention it earlier, but I do host a weekly podcast, the Azure and DevOps podcast, and you can find that wherever you get your podcasts. I have some really, really interesting guests, the Azure and DevOps podcast with Jeffrey Palermo. So you can find those links in the chat as well before you go. But thank you all so much. You've been a great, great class, and hope to see you all and your colleagues on Friday. God bless.